Good morning, this is your Stat Sensei, Mr. Spensei, and this death packet problem is number 41 through 50. When making an inference about a population mean, which of the following suggests the use of z-scores rather than t-scores? All right, we use a z-scores when we know the standard deviation of the population. All right, outliers are absent, true. Population is normal, true. Sample size is under 30. The variance of the population is known. So basically, instead of saying standard deviation, remember this is a standard deviation symbol. This is the variance. If you know one, you know the other. So we use the z when the variance of the population is known. All these others are required for both of them. They're required. Those are required for both. Okay. Under what conditions would it be meaningful to construct a confidence interval estimate when the data consists of the entire populations? Hey, they said the entire population. That means you're taking a census. If you're using a census, you do not need to take it. Matter of fact, it's not correct because you have the actual value. If you have the actual value, not necessary. Our answer choice to this one is E. 43. A fitness center advertises that the average pulse rate of its members is 68.4. HO. Mu is 68.4. A high school AP instructor suspects this is a made up number and runs a hypothesis test on a simple random sample of 48, calculating a mean of 71 with a standard deviation of 10.3. In which of the following intervals is the p-value located? All right, here's a difficult question. He said it was made up. He didn't say which way it was. So since he didn't say which way it is, we have to say it's a not equal to. We can't say it's less than or greater than, right? Yes, 71 tells me it's greater than, but I can't do it that way. I just have to sit there and go, since he didn't say greater than or less than, we can't use it. So stat, test, t-test, mean, 68.4, sample, 71, standard deviation, 10.3. Sample size, they had a 48, and we needed the not equal to because they didn't give us the direction. And we ended up getting a p-value of 0.08. All right, so 0.08, that's between 5% and 10%. So the answer to 43 is D. A national parent organization is concerned that middle school students are spending too much time, more than 8 hours a week, with home video consoles. A study is conducted sampling 150 students. N is 150. What is the appropriate? And the resulting sample mean is 7.95. All right. So HO, well, they believe that it's 8 hours or more. So the alternative is greater than 8. All right. Well, greater than 8 happens to be B. Turns out that they were wrong. It's just under 8, but whatever. Or at least their sample was just under 8. 45. Suppose a fastball speeds in collegiate baseball are normally distributed with a mean of 86 and a standard deviation of 4. Ooh, they're telling us the population. Suppose further that Major League Scouts will only consider pitchers who can throw a fastball at least 90. All right. What percentage of pitchers prospects who are considered can throw at speeds over 95? This is a difficult problem. So we basically have the probability that X is greater than 95 divided by the probability that X is greater than 90. Because they said they're only taking this group and we're gonna do 95. So I need to do a norm CDF because basically we have 86 and we're looking for this area that's 95 or more, and we're going to divide it by 86, but we're going to have a little larger area at 90. So second vars, norm, CDF, lower bound 95, upper bound 9 raised to the 99th, mean 86, standard deviation was 4, and we get 0.0122 for the top value, 0.0122. And for the bottom value, second vars, norm CDF, I'm going to change that lower bound from 95 to 90. Everything else remains the same. And I get 0.1586. Now we're going to have some rounding error. So it's this value divided by that value. And we get 0.077. So about 7.7%. Our answer choice is for 45 is B. All right, 46. The 6.779 kilometer annual boat race between Oxford and Cambridge is watched by an estimated 250,000 fans from the banks of the river. Who knew? The average weight of these crew members has been around 180, but a U.S. sports statistician believes the average weight of all collegiate crews is less than this. So, in a random sample of 50 crew members, a hypothesis in which mu equals 180 and the alternative is less than results in a p-value of 0.078. Using this data among the following, which is the largest level of confidence for a two-sided interval that does not contain 180? All right. So the p-value goes into two tails. All right. So the p-value is going to go into two tails. So we're going to take the 0.078 because we're taking that p-value and we're dividing it by 2. 0.078 divided by 2 is 0.039. All right. So 1 minus 0.039 is 0.961. I said that wrong. The p-value goes in the two tails. So I'm now going to have 0.078 in this tail. And I'm also going to have 0.078 in this tail. So I want to know what's left. All right. So I divided by 2. That was a mistake. I should have added them. 0.078 plus 0.078 is 15.6. 1 minus that is 84.4%. So the max it could be is 84.4%. They don't have that as a choice. So 84% is our best answer. It could have been 84.3, 84.2, 84.1, or anything less than 84.4. It could not be more than 84.4 because this area right here is 0.844. 47. Animal scientists studied foraging behavior of the scrub lizard and found in Central Florida. Foraging is a process of searching for food. To study such behavior, the scientists record the number of head movements per minute for a sample of lizards, 63 lizards. A 95% confidence interval is constructed from a sample is given, okay? 2.7 plus or minus 0.62 head movements per minute. Based on the interval, is the head movement of 3 head movements plausible? Well, let's check plausibility out. To be plausible, it needs to be within an interval. So let's take 2.7 minus 0.62. So it could be as low as 2.08. Let's take 2.7 and add 0.62, and it could be 3.32. So we know that any value within that interval is plausible. Well, three head movements is in there, so it is plausible. So 47 is going to be a plausible answer. So that gets rid of our not plausibles. And it's plausible because it is contained within the interval. So 47 is E. 48. In 1978, or 1978, in 1798, Henry Cavendish used a torsion balance to estimate the density of the Earth at 5.42 times the density of water. A modern day geologist runs a hypothesis and says that it's not that and obtained a p-value of 0.08. If the geologist had run a one-sided test with the same data, what is true about the possible p-value? All right. Well, so here's the deal. It's going to be either with a p-value, we're going to have to sit there and go, well, we're going to have to divide it by 2. So we're going to have a 0.04 because this was a two-tail test. And when you go from one tail to two tail, you double. If you go from two tail to one tail, you halve. So two tail to one tail, you're going to have so 0.08. So that becomes 0.04. Well, that gets rid of this one and this one and this one. Well, we'll explain why it gets rid of this one in a second. But this one is still a possibility and it's the correct answer. And the reason why is you don't know the direction. So it could be 0.04 and then 1 minus 0.04. All right. So because you don't know the direction that they had, since you don't know the direction, it's going to be 0.04 and 0.96. All right. Because you don't know the direction. So anytime you do a two tail, you're going to have to go divide it by 2 from 1 to 2. Excuse me, from one tail to two tail, divide the p-value by 2. So 0.08 divided by 2 gives me 0.04. And then we also have to do 1 minus 0.04, and that gives us 0.96. So it's going to be those two values. So 48 will be E. Number 49. In a random sample of 50 mathematics majors at a large state university, their mean GPA on a 4-point scale was 3.65 with a standard deviation of 0.25. Which of the following is most likely true about the distribution of GPAs among math majors? All right. The central limit theorem guarantees the distribution is approximately normal. No, the distribution of means is approximately normal. So that's false. The sample size of 50 guarantees that the distribution is approximately normal. No, it says that the distribution of means is approximately normal. The maximum possible of 4 would have a z-score of 1.4. The distribution is skewed to the left. Well, where did they get that from? Let's see what happened. So if I say z equals x minus mu over sigma, let's see what happens. We have 4 or 3.65 minus, 4 minus 3.65, and I divide that by 0.25, I get a z-score of 1.4. And what they're saying is, if I were to draw a picture of this, I don't have a whole lot of room, 3.65, my maximum value is 4, and this distance is only 1.4 standard deviations. I need 3 standard deviations above and below. So that means instead of being shaped like this, it's shaped like that. All right. So the distribution is skewed, and it happens to be, if I stretch it this way, it's skewed to the left. So 49, the best answer choice is C. 50. The 40-yard dash is an important diagnostic evaluation tool for all positions in both collegiate and professional football. Which of the following is the best interpretation of a 95% confidence interval? All right, for the mean, 4.67 to 4.87. 95% of all players. No, we don't know that. Um, we don't know about all players. We're only talking about the average. 95% of all players have a mean 40-yard dash between 4.67. That's not the best, but we'll leave it there for a moment. We'll come back to it and see if there's something better. Players run the 40-yard dash between 4.6 and 95% of the time. That's completely false. We're not talking about individual players. We're talking about the average. We are 95% confident that for any given player, his 40-yard, no, not his play. We don't worry about any given player. We worry about the group of players. We are 95% confident the mean 40-yard dash time is between. That's what we believe. That's our best answer. What we don't like here is 95% have a mean. No, the players don't have a mean. It's the mean of the group. So we don't like B because that should have been the mean of the group. All right. So that includes this video. Appreciate you watching, and we'll see you on the next one. Thank you.